Can planes just levitate above the ground and wait for the Earth to rotate? I guess they cannot, but is it possible? This also begs another question. The other day I was traveling in a train, and I thought to myself, if I jump, will I land in the exact same spot, or will the train pass and I will be in a different spot? And off, I landed in the same spot. Why did that happen? During my jump, I was not in contact with the train, and the train was moving at a fast speed. So why did I land in the same spot? The answer. So this is a pretty common question, and the really simple answer is Newton's first law. An object in motion will remain in motion unless acted upon by an outside force. While you're on the train, you're in motion going forward. When you jump, the only force acting on you is a force up, so you do go up. But nothing pushing you back, so you keep moving forward. But this leads to a discussion about how to think about these topics. Think about being on the train. If being in contact with the train is what kept you moving with the train, well, then the only place you're in contact with the train while standing is your feet. Do you feel a strong force pushing the soles of your shoes forward as you move along? Since it's not, it can't be the contact between you and the train doing it. However, when the train is first taking off, or when it is stopping, you do feel a force between your shoes and the train. And if you were to jump while the train was braking hard, you would fly forward into whatever was in front of you on the train. This is because of the same law as mentioned above. When the train is at a standstill, you are too, and the only way to get you moving is to apply a force to you. So as the engine applies a force on the train to get it to move, the train has to apply a force to you, if you're standing through your shoes, to get you to move too. Once you're moving, you'll stay moving unless a force acts on you. So when the brakes apply a force to the train has to apply a force on you to stop you. So if you're in the air for either of these times, the train can't apply that force, and you'll move forwards or backwards. In the train, really, staying stationary is measured by the Earth. Planes are pretty similar. If you live in the US, the rotation speed of the Earth is around 700 miles per hour, faster down south, slower up north, but on average. Of course, when you go outside, there isn't a 700 miles per hour wind in your face all the time. Because the atmosphere is rotating with the Earth, plane and helicopters, etc., are all flying through the atmosphere, and the atmosphere rotates with the Earth. So just hovering there wouldn't get you anywhere new. But even without the atmosphere, the movement you inherit from the Earth matters. For spaceships, it's why we like to launch from down south. In the US, we launch from the tip of Florida. Why? Because we get a speed boost. The rotation of the Earth gives our rocket ship a boost. As it takes off, it also has the speed of the Earth's rotation. So once it's out of the atmosphere and needs speed to get to orbit, that speed is gotten for free. Follow this channel for more Santa Explains. And if you have any questions I should answer, just write them down in the comments.